Determine the sum to infinity of the following series. Okay, let us begin. So here we will be considering the sum. Let Sn represent the sum of the infinite series given by 1 over 3. But we're going to rewrite the first term as 1 multiplied to 1 over 3. Added to, then we have 3 over 9, which is the second term. We're going to rewrite it as 3 multiplied to 1 over 3 squared. Added to, we have 5 over 27, that's the third term, but we can rewrite it as 5 multiplied to 1 over 3 cube. Added to 7 multiplied to 1 over 3 raised to the power of 4. And this keeps on going all the way up to infinite number of terms. Now this particular infinite series denoted by Sn, this is not an arithmetic series because it does not have any common difference, or it is a geometric series as it does not have any common ratio. However, it is constructed of two types of sequence. One will be in arithmetic progression and the other sequence is going to be in geometric progression. Now the reason why we wrote each of the terms in this particular fashion, because here we can see that 1, 3, 5, 7, so these numbers are going to be in a arithmetic progression, and we have 1 over 3, 1 over 3 squared, 1 over 3 cube. So these terms are going to be in geometric progression. Fine. Now, for this geometric progression, the first term, that's 1 over 3, the common ratio, that's going to be 1 over 3. Fine. So here what we'll do, we will take this common ratio 1 over 3 and multiply it with each of the terms of the sum. So that means we have 1/3 of Sn. So this is going to get multiplied to, so if we take the first term 1 times 1 over 3 and multiply with the common ratio 1 over 3, that's going to give us 1 multiplied to 1 over 3 squared. Added to, let's take the second term, which is 3 times 1 over 3 squared multiplied with 1/3, so that's going to give us 3 multiplied to 1 over 3 cube. Added to 5 times 1 over 3 raised to the power of 4. So this keeps on going all the way up to infinity. Now what we have here is we have two sums. We're going to take the difference. So we'll take sum up to infinity. Now this is infinity, and we're going to subtract 1/3 of the infinite sum from it. So the first term that's going to stay is 1 over 3. Then we have 3 times 1 over 3 squared minus 1 times 1 over 3 squared. So that's going to give us 2 over 3 squared. Then we have 5 times 1 over 3 cube minus 3 times 1 over 3 cube. That gives us 2 over 3 cube. So this is going to go on all the way up to infinite number of terms. So here we have 2/3 of the sum of the infinite terms. This is going to be equals to 1 over 3. That's the first term. But the sum of the remaining terms, excluding the first term, that's going to be a geometric series. So clearly here, the first term A, that's equals to 2 over 3 square, or you can say it's 2 over 9. And the common ratio, that's going to be 1 over 3. And we know the sum to infinite terms of any geometric series, that's given by A over 1 minus the common ratio R. So when we use this, then we have 2 over 9 divided by 1 minus 1 over 3. So let's now further simplify. We're going to get 2/3 of the sum to infinite terms, that's equals to 1/3 added to, now we have 2 over 9 divided by 1 minus 1 over 3, so that's 2 over 3. But that leaves us with 1 over 3. We have 2/3 of sum of the infinite terms equals to 2/3. So simplifying, we get sum of the infinite terms that's equals to 1, which means that the sum to infinite terms of this series 1 over 3 plus 3 over 9 plus 5 over 27, this sum is going to be equals to 1.